Trigonometry, grade 11. And the moment I say the word trigonometry, you think? But what is trigonometry really? It's the study of triangles. That's what trigonometry means. It's the study of triangles. It's all about triangles and the measurements of the sides together. Because now you can tell me that sin is opposite over hypotenuse, right? Cos is adjacent over hypotenuse, tan is opposite over adjacent. We're going to get back to that. But I'd start somewhere a little bit different than what the ATP says we must do. You can go check in that ATP. Please sit still. That this only comes after the graphs. We are going to do all the trig according to them, and then we're going to go back to algebra and do parabolas and hyperbolas and exponential graphs, and then only after that comes the trig graphs. I have a very specific method in that and a reasoning because I do that. It's all about, if you know the graphs, there's a lot of stuff you can just know. For instance, if I tell you and ask you now, what is the sin of 90? Who knows what the sin of 90 is? You should know that it's 1 because you're remembering from last year when you did the mother graphs, because I'm going to do the mother graphs for you now. The mother graphs, that sin graph starts at 0, then at 90 it's 1, 180, 0, 270, 1. Okay, now I'm going to make them big fat points like that, which you must please not do, but I'm making a point here. You were told last year as well that those 5 points are the mother graph's basic points. So when you know those 5 points and you know in your back of your mind that the sin graph looks like this. Are you with me? Not straight lines, it's a curve. It's a nice smooth curve because you get a mark for the shape. So it's got to be a nice smooth shape. So there are 5 points that you must know. And those are the 5 points. Now what about if I go to the left-hand side? Because now there's a lot of things happening here. Why is this so? Because it comes from, in a triangle, when you go and measure the opposite over the hypotenuse, and this was 5 degrees. You get the answer for 5 degrees is 0, 0, whatever. And it comes from somewhere and it's all programmed into your calculator. That's where it comes from. And all of this makes a certain figure. It's like a recipe, it's like a function. There is a certain rule that comes from it. There is a pattern going on. And the pattern is the sin curve. Right? You must have heard about the sine curve somewhere already in your life, showing a sine curve like this. Now from 0 to 360, that's usually where we sketch. But does this go on? Yes. Until infinity. Yes. And to the negative side as well. So it's important that you know, I'm going to ask you to sketch in a certain specific area, the domain. I'm going to restrict you and say, listen, I want you to sketch there, and that's what you're going to do. Sketch from negative 360 to positive 360. If I asked you just to go to 180, then you would have stopped there. And you get marks for not doing what I'm asking you to, or not marks. Alright, now if it was to the left-hand side, you can just carry on with those 1, 2, 3, 4, 5 points that you know of by heart of the sine mother graph. And let's go to the left-hand side. So this will be negative 1, 0, positive 1, 0. Alright, and we make sure that we've got our curve going. Something to take note of. Say for instance I told you to stop there at 90. Then you can't just go straight down to 90. You've got to show me that you know the pattern will go upwards again. And I'm making my way to going upwards again, although I stopped there. If the sun had said go from minus 90, then I would have stopped there. But you see what I mean? So you must make sure I can see that you're getting ready to go back up. That's the pattern, or that is the shape of your graph. So over here, we're going down, and we're going down. See the curve? If I ask you to stop there, it's making itself ready to go back down again. And the same thing to that side. And so it will continue to infinity. You just sketch it wherever I ask you. Something to take note of for later on is when I do these graphs, we always go with our degrees from 0 to positive infinity, 0 to negative infinity. That's one way of measuring it and saying the sin ratio will be, the cos ratio will be. What I was speaking about just now is if I want to do a little triangle sketch, and I'm talking about, let's say, 500 degrees. Where's 500 degrees if I actually measure it? Now, standard form, because it's something I'm going to refer back to in the future. Standard form for an angle, when I actually want to measure 30 degrees or 50 degrees or whatever the degree is with a compass and a protractor, then I always measure it from positive x-axis. And I always measure it anti-clockwise. That is a positive angle. Say, for instance, that was positive 100 degrees. So it will be anti-clockwise. If it's a negative degree and you want to actually measure it, you're going to go still from standard form on the positive x-axis, but you're measuring clockwise. Now, what I'm getting at is this. If this is my angle, then you're just going to say, well, 360, 360, 360, and all the revolutions that your little engine or whatever makes to get to a certain amount of degrees. Are you with me? That there's two representations. That if I speak about, say, 1,000 degrees, you're going to have to go over and over and over again. Like, for instance, this one might have been something like minus 800 degrees. Because it's in the negative direction, and it went 360, 720, and something. Must be more than that. Let me make it. I can't figure out exactly now, but are you getting the idea? Representation here is from 0 up to 360 and from 0 up to negative 360. Over here, it'll go 0, 90, 180, 270, 360, and then again and again and again in that representation. So that you know what an angle in standard form is, and that you also know how this can be represented on a graph. Because now here you can see the sin curve forming. Over there you wouldn't have seen it. You just go to the degrees wherever it was. Okay? Back to the basics that you already know about these graphs. What is the amplitude and the period of the normal mother graph sin? The amplitude? 1. What is that? That's the highest and the lowest value that this graph can ever reach. So that was 1. So it's actually from resting the maximum that it ebbs out to the both of the sides. So that's your resting period, and it goes out maximum 1 unit and 1 unit. This is not negative 1. It's 1 unit. The amplitude could be negative 1. The amplitude is the length, which is 1 unit. The period? 360. What does a period mean? Like our periods now are 30 minutes. Right? Period is how long does it take to make a complete sin curve. Starting, going up, down, and up again. That's a complete sin curve. And that's going to change this year. Because it was always last year for any sin graph, 360 for a period. Always. You didn't even have to look at the sum, you knew it was 360. This is going to change now. Last year what we did do with this, and this is going to be our next sums, if we did say there's a 2 in front there, what did it change? This was a 2. The amplitude changed to 2. That's actually the amplitude that's over there, which is a 1 at the moment. If that was a 2, then you go to your mother graph, the 5 points that you've got, and you take every y and time it with 2. So 0 would still stay 0, the y. But the y of 1 will times with 2 and get to 2. 0 will still say 0. Negative 1 times 2 is negative 2. So see the graph stretching like that. That was grade 10 work. Yes. Stretching and shrinking vertically. The other thing that happened last year is if I said, for instance, plus 1, then this whole graph shifts. As is, you're picking it up and shifting it up 1. So that'll be at 1. That'll be at 2. 1, 0, 1. And there's your graph. Vertical shifts, vertical transformations. This year, horizontal. So it's going to move left and right, and it's going to shrink and stretch left and right. That's the new work. Okay, but it's all coming from your mother graph. So let's quickly go through cos and tan, the stuff that you already know. There's nothing new there. Maybe you've just forgotten a little bit about the standard form or an angle in standard position. If I go to cos, something just to take note of. This is always my angle axis. It's not x. It could be cos x, and then you'll call it x, but this is the angle axis. That's why it isn't 1, 2, 3, 4, 5, 6, whatever, it's angles. Where the y value is still y, because it's the answer for the ratios that you've got here. Remember that sin of an angle, cos of an angle, tan of an angle is a ratio. These ratio answers I'm representing here in terms of y. So if I start off, where did we start the cos? 1 and 1. And 0. And 180 was negative 1. 0. Okay. 1. And make like a little bucket. Like in Afrikaans, they talk about kos is like food. So we got a kos bucket. Okay. Are you with me?
Yes, ma'am.
Do you also see my pattern again? Because I'm not going to go on here, but I'm making ready that it can go down again. And the same thing here. You don't do this. It's turning. So it's going down, upward like that. And this is a good method of sketching it when you want to make your little patterns nice and smooth. Alright, and then to this side, let's continue. There's 1, 2, 3, 4, 5 points. Are we with each other? Those are the knowledge points that I want from you. Because after this, I'm going to say mother graph. What do we do with it? Time the x, divide the x, add to the x, to subtract to the x, all with the y's that we've just spoken about. You need to know your mother graph so that you can transform. If you know this, you'll be fine. Some people want to do it with a calculator, and if you don't know exactly what you're doing there, you fall off the wagon. So please remember that. So to the left-hand side, we've got 0. And if all of a sudden your graph does strange things, you must know it's not right.
Bosop is al besig, so dit volg toesig vir haar voorklas gaan jy 'n toetsperiode na A13 toe, daar sal onderwysers kry. Ms. Bosop is absent, please form class go to A13 and do the test lesson. If you pick up a bunch of keys, please bring it to the front office. As jy wil steeds opgetel het, asseblief bring dit na die voorkantoor toe. Baie dankie.
Right?
You stopped it.
Oh, just the word. Thank you. The period is 360 and the amplitude is 1. Thank you. Well, I've given you your marks at the exam. I can see you also missed it, but guys, you have to have the right answer for the right question. So yes, that was wrong. 10. So did the period ever change in grade 10? No. Sin, I don't care what it was in grade 10, it was always 360 period. Cos 360, tan 180. Excellent. Let's see how. Do you see the difference in my general graph of the mother graph of sin and cos and tan? What happened here? I need smaller intervals because I need to see the 45. It's a mark. You have to know that special angle, that tan 45 is equal to specific, not just I know it goes something like that and there you go your graph. It's got to be exactly on 45 and exactly on 0. So there's 2 points already that you must know. There were 5 points and 5 points to know off by heart. Then the next one, what was the other thing that happened here? At 90 it was an asymptote. Excellent. 90 it goes closer and closer and again with the shapes. This has got to go upwards, shaping inwards to there. If you do this, you're going to crash into the asymptote. Now what's the asymptote? It gets closer, but it never intersects. If you do that, you're definitely on your way to intersect. And then you will get a mark deducted because of your shape. You've got to show me that it's coming closer, but it will never touch. So, where's the next asymptote? Because that's always the nicest thing. 2, 7. When you start sketching them, do your asymptotes first. There you see your little barriers. The next one here would have been at minus 90 and minus. And then 90, 540 would be the next, and the next, and the next. But all of the time, exactly 180 apart. 180 apart. And you're going to see your little tan, snaky thingies, curvies there. Always going to look the same. So, for the next step, it will be at 180. This one would be at negative 1. Which one is it? 135. Because it's always 45, 45, 45. Further. Here would be 225. And if it's too small, start writing it maybe like that. Are you with me? There's techniques inside of your graphs. And on this side it would have been at 1. Now it almost looks like a straight line. You better see that it's not a straight line. And see that it curves upwards. One is a little bit higher there. Curves upwards and it curves downwards. Guys, there's a correct way and there's a wrong way. Do it the correct way. And over here then, the little snake is not going to be finished. I'm only going to get to this bottom piece here with the piece that I'm sketching. But it does go up until 540 and 540 is the next one. And so it'll continue. So here we're going to continue with -1 and -45. And then again curving it downwards. So do you see the little snake is going all the time the same way? This side, again, 0 there, -1 there, +1 there. And it curves upwards and it curves downwards. Perfect. And in this piece, we're sketching here. No, right? Upwards. Oh, see, I'm trying to confuse you to make sure you understand. It's always going to look that same. So that should be at 1 there. And then at 0, curving upwards again. So what do you need to know off by heart is these 1, let me make it black. 1, 2, 3, 4, 5, 6, 7 points plus the asymptotes. Which asymptotes? I'm just talking about these two. But if you know them from 0 to 360, you can apply them anywhere else. So it is going to change this year. Because these graphs are going to go and stretch. So then obviously the asymptotes will also go in coordination with that as well. Alright, and then also move up and down. Last year, yes. Move 1 up, so 1 up, 1 up, 1 up, 1 up. And everything goes according to the 7 or the points that you've already got. You just go according to that. So that's, and I didn't say space here for amplitude, but let's say amplitude doesn't exist. Because there is no maximum. And then lastly, what is your period? 1 is